Hi everyone, I'm here with the 2023 AMC 12B. Problems are produced by the MAA. So question one, we have 4 glasses of orange juice, 3 are full, 1 is 1/3 full. And we want to pour juice out of the full glasses into the not full glass so that they all have the same amount. So how much juice do we have? We have 3 full plus 1/3 full gives us 10/3 cups of juice. We're going to divide that into 4 cups, which gives us 5/6 of a glass of juice in each, which means we have to pour 1/6 out of the full ones. Carlos is buying shoes. Shoes are reduced by 20%, and then there's sales tax. He has $43. So what's the most expensive shoes he could buy? Well, if the starting price is X, first we're going to reduce it by 20%, then we're going to increase it by 7.5%, and that's supposed to equal 43. Now 4 times 1.075 is 4.3, and we'll multiply both sides by 5. And so it looks like X is going to be $50. We have a right triangle inscribed in a circle. That means that the hypotenuse is the diameter of the circle. We have another right triangle inscribed in a different circle. What's the ratio of the small circle to the big circle? Well, the ratio of the area is equal to the ratio of the diameter squared. Paintbrush makes a strip with width 6.5 and length 25 meters long. How many square centimeters can we cover with paint? Well, we're going to do 0.65 centimeters, that's millimeters converted to centimeters, times 25 meters, that's 2,500. And so if we move the decimal 2 places here, we're going to move it 2 places there. So all the answers are the same number except for times some power of 10. It looks like our answer should have 5 in the units digit, so it better be C. Okay, in this game, there's 1 domino on a 3x3 grid. We don't know which squares are covered, but we want to find at least 1 square that is covered. And so we're going to guess a square. What's the minimum number of turns we need? Well, the way I'm thinking about it, we can't have any 2 adjacent squares uncovered, so I can definitely win in 4 turns. And now I should double check, is it possible to win in 3 turns? Well, I have to have at least 1 dot in each row, and also at least 1 dot in each column. But if I only have 1 dot in each row, that has to be in the middle, because otherwise, if I put it on the edge, I can have a domino like this. But if it has to be in the middle, then I'm going to have a domino on the edge. So 3 doesn't work, so it has to be 4. Okay, we have a polynomial with a lot of repeated factors, and if I remove the roots, then I will have disjoint open intervals, and on how many of those intervals is p positive. So we're just going to make our number line x-axis, and we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if x is bigger than 10, every factor is positive. And then every time I have a root, I will either change signs or not change signs according to the multiplicity is even or odd. So 10 has even multiplicity, so you don't change sign, it stays positive. 9 is odd, 8 is even. So we're going to have this pattern of changing every second 0, every even multiplicity 0. And counted up, I've got 6 pluses, 6 intervals where p is positive. For how many integers n does this expression represent a real number? We're talking about log base 10 here. So it's a real number as long as the thing inside the square root is a non-negative. So we'll use some rules of logs here. So log of n squared is 2 log n, and then I can factor out log n. So so what I need is for log n times 2 minus log n divided by log n minus 3 to be non-negative. So what are the critical values for this function? Well, n has to be bigger than 0 because we're taking a log of it. And we're going to have a vertical asymptote, right? We're going to, when log n equals 3, in other words, when n is 1,000, we're going to have a vertical asymptote. The expression will change signs. When log n equals 2, in other words, when n is 100, or when log n equals 0, in other words, when n is 1, right? Those are going to be the zeros. And so actually, this problem is very similar to number 6. We have our factor line analysis. If n is bigger than 1,000, then my factors are positive, negative, and positive. So the function is negative when n is bigger than 1,000, and we're going to change sign. The multiplicity of each critical number of each factor is just 1. So we're going to change sign on each of these. Now I'm only interested in integers. And so we see that the largest integer is 999, where where this number is a real number. And and we're going to remove all the integers less than we're going to remove all the integers less than 100. So we'll remove 99 integers except for number 1. So we'll add that one. So 999 minus 99 plus 1 gives me 901 solutions. How many non-empty subsets of the set of integers from 0 to 12 have the property that the number of elements is equal to the least element of B? For example, this is a 4-element subset where 4 is the smallest element. Okay, well, let's make a table of values here. So n can be anywhere from 0 up to 12, and then number of B that have n as the least element. Let's count them up. Well, 0 doesn't have any examples, and 1 only has 1. Right? The only subset with 1 element is 1 itself. For 2, though, if I have 2, then now I have 10 numbers, from 3 up through 12 for the second possible element. So 2 is going to be, I'll write it this way, right? 2 is definitely an element, and then the other element, there's 10 choices, and I'm choosing one of them. If 3 is the smallest element, then now there's 9 other numbers bigger than 3, and I have to choose 2 of them. And so it looks like this pattern is going to continue. If 4 is my least element, there's 8 numbers bigger than 4, and I have to choose 3 of them. There's 7 numbers bigger than 5, and I have to choose 4 of them. There's 6 numbers bigger than 6, and I have to choose 5 of them. There's only 5 numbers bigger than 7, and I can't choose. 7 can't be the smallest number in any of the subsets of this type. So this is my answer. I have to add up these numbers. So it's 1 plus 10 plus 9 choose 2 is 9 times 4. 8 choose 3 is 8 times 7 times 6 divided by 6. So it's 8 times 7. 7 choose 4 is 7 times 6 times 5 divided by 6. So 7 times 5 is 35. And 6 choose 5 is 6. Add them up. We're going to get 11, 47, 103, 138, 144. 144, 12 squared. I wonder if there was a better way to count that. When you see 12 squared for an answer of something that depends on 12, you wonder. Okay, what's the area of the region in the coordinate plane? There probably was a better way to count that. What is the area of the region defined by this inequality? So I've got this same sort of expression, once with x, once with y. Let's think about what this expression looks like. You know, if I just call this f of x, what the graph of f of x is going to look like an absolute value function shifted down by 1, and then I'll flip, and then the outside absolute value is going to flip this negative part up. So the graph is going to look like this kind of sawtooth. And so if x is bigger than 2 or less than -2, then this expression is already bigger than 1. And let's think about what happens now. When is this inequality going to be satisfied? Well, if x equals 0, then this first term is already 1. And so the second term for y must equal 0, which means that y would either be 1 or -1. That's the only value that make this second term equal to 0. Then as x, let's say as x increases from 0, the value of the first term is decreasing. And so the value of the second term can stay at 1 or -1, or it could increase by the same amount. And so the possible values for y are going to be increasing at the same rate that the possible values, that the value of x decreases. All the way to the point where x equals 1, then the first expression is 0, and the allowed values of y are anything from 2 down to -2. So we're going to get this symmetric action as x is bigger than 1. The allowed values of y are going to look like this. So it looks like the inequality is satisfied in any of these regions. And then by symmetry, right, is absolute value of x and y, we'll have two other identical squares over here. So these squares, the side length is the hypotenuse of a 1, 1 root 2 right triangle. So there's 4 squares. Each one has area root 2 squared. So it should be 2 times 4 is 8. Okay, we've got a circle with radius 4, centered on the positive x-axis, tangent to the y-axis, and another circle radius 10, center on the y-axis, tangent to the x-axis. What is the slope of the line passing through the 2 points where these circles intersect? Let's try to draw the picture. The radius of this one is 4. And the radius of this one is 10. Or maybe something like this. And so I want to find the slope of this line. So one intersection point is the origin itself, and the other is over here. So how can I find the slope of this line? I think that what I have to see is that this maroon curve is a chord of both circles, and so the perpendicular bisector of this chord is going to go through the center of both circles. All right, and so the slope of this perpendicular bisector I can find easily. It's going down 10 and right 4, so the slope is -5/2, and that means the slope of this guy is the negative reciprocal, which is 2/5. What's the maximum area of an isosceles trapezoid that has legs of length 1 and one base twice as long as the other? All right, so it's isosceles. The picture looks something like this. Sorry, my pen sometimes needs to be reset by scribbling. Do that right now. So if I drop the height here, right, then this should be x, and each one of these should be half x by the symmetry of being isosceles. And so the height is going to be the square root of 1 minus x squared over 4, which I'll write as the square root of 4 minus x squared over 2. So the area is going to be half the length, half the sum of the top length plus the bottom length, the average of the two parallel edges. So 3/2 x times the height, which is root 4 minus x squared over 2. Okay, so it almost feels like a calculus problem to ask for a maximum value of this function. But I don't think we have to use calculus here. If I square the area, I'll still be looking for the looking for the maximum. So area squared is going to, and let me multiply by 4 also to get rid of my fraction here. So so 4 times the area squared is going to be 9x squared times 4 minus x squared. And so this looks like a parabola in terms of the variable x squared. It looks like a quadratic in terms of x squared. And this quadratic equals 0 when x squared, so equals 0 when x squared equals 0 or 4. And that means it's going to have a maximum value when x squared equals 2. Okay, so x should equal the square root of 2 to get a maximum value, and now I just need to plug that in to my area function over here. All right, so divide by 4 again. So I'm going to have, my answer should be 3 times square root 2 times the square root of 4 minus 2, so times square root 2 again, and then divided by 4. So it's going to look like 3/2. Good. All right, we have a new rule, this kind of circle product of complex numbers is another complex number defined by this rule. And I want to find complex number so that z circle product with itself equals z squared plus 40. If that's the case, what is the size of z? Well, if I suppose that z is a plus bi, let's just write down the left and right hand side of this equation, right? Then z circle across z is going to equal a squared plus b squared I. But on the other hand, 40 plus z squared, well, the real part is going to be 40 plus the real part of z squared. So z squared is going to be a squared minus b squared plus, now the imaginary part of z squared is 2abi. And so if these two numbers are the same, then they have to have the same real part and the same imaginary part. And so the real part, right, if these two numbers are the same, then that tells me that b squared has to equal 40. So b squared equals 40, b equals 2 root 10. And if the imaginary parts are also the same, then it looks like I have 40 equals 2a times 2 root 10. So in other words, a, divide out the 4, divide out the root 10, a equals root 10. And so the size of z should equal the square root of a squared plus b squared, which is going to be the square root of, so b squared is 4 times 10, so 40, and a squared is 10, so square root of 50. Knock out the 25 here, so 5 root 2. Okay. We have a rectangular box with distinct edge lengths A, B, and C, and the sum of all the edges is 13. So the sum of all the edges is A plus B plus C, but there's 4 of each edge, so that's 13. The sum of the area of the 6 faces, that's AB plus BC plus AC, and there's 2 of each face, so that equals 11 halves. And the volume is 1/2, that's ABC is 1/2. Find the length of the longest interior diagonal connecting 2 vertices. So that's going to be the longest interior diagonal is going to be from one corner to the opposite corner, and so we're going to be looking for square root of a squared plus b squared plus c squared. So okay, I know what a plus b plus c is. I'm looking for something involving a squared plus b squared plus c squared. So maybe I'll just square a plus b plus c. And so from the first equation, that should equal 13 squared over 4 squared. But if I just expand it out, it's going to be the thing I'm looking for squared, right, plus all the cross terms. And all the cross terms, we're going to have 2ab, we're going to have 2bc, and we're going to have 2ac. That's exactly what I have in the second equation here. So x squared plus 11 halves. So x squared should equal 169 minus 88 all over 16. So 81 over 16. And so take a square root, you get 9 over 4. For how many ordered pairs of integers does this polynomial have 3 distinct integer roots? Well, 6 is the product of the roots, and so the possible roots are like 6, 1, and 1 is possible, or 2 of these roots could be negative. And so if 6 is negative, one of the ones is negative, or if 6 is positive, then both of the ones are positive. So we have like 6, 1, 1, or minus 6, minus 1, 1, or 6, minus 1, minus 1. And so there's only 3 ways to have roots like this. We could also have the 3 roots be absolute value 1, 2, and 3. And now in this case, this one or any 2 of these 3 could be negative. And so there's 4 possible ways to arrange that. And each one is going to give me a different polynomial. So it looks like I have 7 possibilities here. Okay, A, B, and C satisfy this equation. So we're adding fractions. 210 is the least common multiple of 14 and 15. 2 times 7, 3 times 5, 2, 3, 5, 7. So which of the following statements must be true? So statement 1, GCD of a and 14 equals 1. So we're always looking at the GCD of the numerator with the denominator of one of the fractions. And so the interpretation of this statement is that a over 14 does not reduce. So is it true that if either one or both of the fractions on the left does not reduce, then the fraction on the right does not reduce? Well, I think that if you have one, but this or is the key part, right? If you have one fraction reducing and the other one doesn't, so if only one of these 2 facts is true, then one of the fractions on the left will reduce. And then we're going to lose one of the factors in the denominator. And so 1 is definitely false. And it looks like 2 and 3 are partial converses of 1. So if the fraction on the right does not reduce, then at least one of the fractions on the left does not reduce. Versus if the fraction on the right does not reduce, that is equivalent to both fractions on the left not reducing. Well, if 3 is true, then 3 implies 2. 3 implies a special case of 2, right? 2 says that, yeah, 2 is like, yeah, so 3 is like a stronger version of a special case of 2. And so let's look at our options real fast. 3 only can't be true because 3 implies 2. And the other options all have 1 in them. So it has to be 3 and 2 only. And I think that makes sense. If the fraction on the right reduces, then the fractions on the left, if the fraction on the right does not reduce, then neither of the fractions on the left reduce. So we already said that's why 1 was incorrect. On the other hand, if neither fraction on the left reduces, then the fraction on the right should not reduce either. And that makes sense. That might be a little harder to verify, but we already know that 3 implies 2, so we should be done. In the state of coin land, we have coins with values 6, 10, and 15, and suppose X is the value of the most expensive item that cannot be purchased using these coins with exact change. What's the sum of the digits of X? Okay, so don't read too much into this. They ask a question this way just so that you can't quite as easily guess and check the answers based on what's given. So, so 6 is the smallest number. So there's not going to be, once you find 6 numbers in a row that can be made, then all the other ones, like every number after that, is going to be made. So I think, yeah, we can start thinking about a number like 14, right? 14 cannot be made by any of these combinations. And so, 15, 16, 17 can't be made either. 18 can be made. 19, that's not going to work out. 20 can be made. So yeah, I think we can kind of guess and check our way a little bit here. I think 29 is going to be a good number to look at because 29, yeah, 1 less than 2 times 15. And so 29 cannot be made. If I don't use any 15-cent pieces, then I can't make 29 because 6 and 10 are both even. If I do use a 15-cent piece, then I can't make 29 because there's 14 left over, and I already know I can't make 14. So let's work. And on the other hand, 30 is easily made. 31 is going to be 1 of each, a 6, a 10, and a 15. 32, yeah, I think it's even going to be easier to work backwards from 29. Right? So 31, I can make 25 plus a 10. 26 is easy, 10, 10, 6. 27 is easy, 6, 6, 15. 28, 6, 6, 6, 10. And then 29 can't be made. And 24 is, yeah, okay. So we're going to have 6 in a row from 30 through 35. And therefore we can just add 6 cent coins from any of these. So 29 is the biggest number. 2 plus 9 is 11. All right. Little bit of a sloppy problem. 3 side lengths of a triangle are in arithmetic progression, and the shortest side length is 6, and we have an interior angle of 120. So we want to find the area of the triangle. So we have 6. 6 can't be opposite one, like the longest leg is opposite the largest angle. So let's draw our 120 over here, and we're going to have 6 plus x, and we're going to have 6 plus 2x. And so I guess we can calculate x using a law of cosines, and then we can calculate the area as 1/2 AB sine theta, right? So, so let's use our law of cosines. So 6 plus 2x squared, 36 plus 24x plus 4x squared is going to equal 6 squared plus 6 plus x squared plus 2 times 6 times 6 plus x, sorry, minus, I'm jumping ahead, minus 2 times 6 plus x times cosine of 120 degrees, but the cosine of 120 degrees is negative 1/2. So that's going to cancel out with the negative 2. So it'll be minus just 6 times 6 plus x plus 6 times 6 plus x. Okay. All right, so here's our equation for x. Let's group, and the numbers are a little uncomfortably large, but we're up to number 17, so I guess we have to deal with it. Cancel the 36 out of both sides, and then I'll write my quadratic over here. 4x squared on one side, single x squared on the other. 24x on one side minus 18x gives us 6x. And then we have 72 left over, so minus 72 equals 0. Let's knock out a 3. So we have x squared plus 2x minus 24 equals 0. That factors nicely with 6 and 4. So x plus 6 times x minus 4 equals 0. X is positive because 6 was the smallest length, so x equals 4. Okay, good. So I can calculate my area. My area should be 1/2 times 6 times 10 times the sine of 120, which is root 3 over 2. And so it's going to be 3 times 5, 15 root 2, 15 root 3. Answer E. Oh, a lot of words here. Okay. Last year, Y and Z took different courses that did not have the same number of quizzes, did not necessarily have the same number of quizzes during each semester. Yolanda averaged on all the quizzes in the first semester, 3 points higher than Zelda's. Yolanda's average on the second semester was 18 points higher than her first semester, and again, 3 points higher than Zelda's. So which of the following statements is true? Is it possible Yolanda's average was 22 points higher than Zelda's over the whole year? Is it possible Zelda's average was higher than Yolanda? Okay, so if you've seen this kind of thing before, if you haven't seen this kind of thing before, then D is a tempting option. If Yolanda beat Zelda in both semesters, then surely she had a better average. But that is called Simpson's paradox. That's not necessarily true, because they both did better in the second semester. And if there were more quizzes in the second semester, Zelda's average might end up being higher. So let's say that, let's say the smallest number, let's say alpha, first letter is Zelda's average in semester 1, right? And so, both persons' overall average is going to be a weighted average of their semester average times the number of quizzes in that semester. So Yolanda's overall quiz average for the year is going to be some number times alpha plus 3, right? Plus, so C is the fraction of quizzes that were in the first semester. Right? And then 1 minus C is the fraction of quizzes in the second semester. So this is Yolanda's average. Zelda's average is a different fraction, potentially different fraction. Sorry, the 18 was the difference from the first semester to the second, so it should look something like that. So if we simplify these, the C alpha plus 1 minus C alpha is just alpha, right? And then we're going to have, so it's going to be alpha minus 18 C, right? Plus 3C minus 21C. Whereas Zelda's overall average is going to be alpha minus 18K. Just a second, something feels wrong here. Yolanda's average in the first semester, yeah, so Yolanda's average in the first semester was 3 points higher than Zelda's. In the second semester, she did 18 points better. That looks good. So C alpha plus 1 minus C alpha is alpha. 3C minus 21C is negative 18C. Oh yeah, plus 21. Got to distribute the 1. Got to distribute the 1 there. All right, now if we're comparing these two, how much better did Yolanda do, right? Y minus C is going to be 3 minus, let's say, plus 18 times K minus C. And so K and C are both fractions between 0 and 1. And so K minus C could range anywhere from -1 to +1, endpoints not included. But no matter what, K minus C is not bigger than 1. And so Yolanda might have done better than Zelda, but the maximum she could have beaten Zelda by is 21 points. So Yolanda cannot possibly have had an average 22 points higher. Okay, I stumbled a little bit on that one. It's a little bit intricate there. Each of 2,023 balls is randomly placed into one of 3 bins. Which of the following is closest to the probability that each bin will contain an odd number of balls? So is closest to means that either we don't have to calculate the probability exactly, or the probability is going to be some number that's so ugly, but it's going to be close to one of these guys. So the way I'm thinking about it is we have an odd total number of balls, and so each bin is going to have roughly 1/3 of the balls, but it's possible, O for odd, it's possible that the 3 bins each have an odd number of balls. It's possible that 2 bins have an even number and 1 bin has an odd number. And there's 3 ways that can happen. But it's not possible to have only 1 bucket with an even number, right? Because that would give you an even total number of balls. And it's not possible that all 3 buckets have an even number of balls either. So there's only 4 possibilities. And are these 4 possibilities all equally likely? Probably not. But I can transition from one possibility to another. For example, by just changing 1 ball out of the 2023. For example, if I take 1 ball from the first bucket here and move it to the second, then I go from odd, odd, odd to even, even, odd, right? And conversely, if I take a ball from an even bucket and move it to another even bucket, I'll go the other direction. And I can do that. And so I can transition from any state to any other state with moving just 1 ball. So that leads me to believe that these 4 states are all pretty close to equally likely. Now, I think the only reason that it's not exactly 1/4 is that sometimes, like some of the movements are impossible because it's possible that one of these even buckets has actually 0 balls. So I can't transfer from 0 to, I can't have -1 balls in one bin. So, except for that small exception, there's a correspondence between these 4 states. So they're almost equally likely. I'll say 1/4 is the answer. Maybe we can calculate the probability exactly, but I don't think we have to. All right, Cyrus sits on a flat surface. He jumps landing 2 feet away, and then he chooses another direction at random and again jumps 2 feet. What's the probability after the second jump that he lands within 1 foot of his starting position? So without any loss of generality, he starts at the origin and he jumps to 2 on the x-axis. And so his second jump is going to be somewhere on the circle of radius 2, centered at 2. And the question is, how many, I guess, what fraction of the points on this circle are inside the circle radius 1 centered at the origin, right? So it looks like what I'll have to do is calculate twice this angle. There's going to be a symmetric situation here. So this angle doesn't look hard to calculate. I've got distance 2 for both of these legs because it's the radius of this circle, and this distance is 1. And so probably the easiest thing to do is bisect this angle, and I can say that the sine of theta over 2 should equal 1/2 over 2, should equal 1/4. All right. And my answer is going to be, well, I've got 4 copies of theta over 2, so my probability should be 2 theta, which, well, I have an equation for theta over 2, so I'll write it's 4 times theta over 2 divided by any of the 2 pi possible directions that you could have jumped. So theta over 2 is arc sine of 1/4, and then 4 over 2 is 2, so it's going to be E. Okay, a lampshade is made in the form of the frustrum, which means a truncated right circular cone. The height is 3√3, the top diameter is 6. So let's untruncate my cone. So the height here is 3√3. The diameter of the bottom is 12. So the radius there is 6. And so that radius is 3. And so bisimilar triangles, right? This top triangle has the same is like half as big as the bottom. So the entire height of the cone, including the tip, is going to be 6√3. The entire height of the cone is 6√3, and the base is the radius here is 6, which means that so this angle. So the length from vertex to bug is going to be 12. Right, we have a 30, 60, 90 right triangle here. So what we're going to do is to find like the shortest distance, we have to slice this surface and then flatten it out, and we're gonna see, like, if it was a whole cone, then it would be a wedge of a circle, but now it's going to be like a part of a donut, right? So if I unroll it and I put it with the vertex, let's say that we put the vertex onto the origin, and we lie it out so that the honey is here, distance 6 from the vertex, and the bottom edge is here, distance 12, then we're going to have some kind of, so how big is it going to be? We're going to have some kind of annular region. The lampshade itself is going to be, this region between 6 and 12 with some angle. So the diameter at the top was 6, radius 3, so it's going to be 6 pi is the length of the top circle. 6 pi, but radius is 6. When we unroll it, that's exactly half a circle. Right? And the bottom is the same. The circumference of the bottom circle is 12 pi, so we're going to have exactly a half circle, and we cut and unroll the lampshade. And so if the honey starts here, the bug is halfway around the base circle, and so the bug starts here. And so the bug walking the shortest possible path while staying on the lampshade is going to go until he hits in a straight line until he hits the rim, and then following the top rim. And what point is he going to go to? Well, he'll go to the point where his path of travel is like a tangent to that point on the rim. So we can calculate that distance. We have 6 for the base of this triangle. We have 12 for the height. And so once again, we have a 30, 60, 90 right triangle. And so this one's going to be 6 root 3. And so chasing some angles here. Right, this is the 30-degree angle. This is the 60-degree angle. So this one is, again, 30 degrees, or in radians, pi over 6, which means that this arc is pi over 6 times 6, or just pi. And so my answer is 6 root 3 plus pi. Cool. All right, we have a real valued function. For all real numbers, this equation holds. So which of the following cannot be the value of f of 1? Okay, so usually for problems like this, you want to get a foothold by looking for some special values. It looks like if I let a and b both be 0, I'll get a nice equation. So 2 times f of 0 is going to be 2 times f of 0 squared. So f of 0 should be either 0 or 1. And when I look at it a little bit closer, if f of 0 is 0, and like I can think of a special case. What if f is always 0? Right? Then the equation will always be true. Okay, it's kind of trivial, but that means that f of 1 might equal 0. So we can eliminate one answer there. And actually, when I think about it even more, what if f of x equals 1 for all values? Then we have 1 plus 1 equals 2 times 1 times 1. So that's also kind of trivial, but I can quickly eliminate 2 possibilities. It's getting late in the test. If I have to guess, if I feel like I want to guess, then guessing out of 3 is not so bad. But okay, we can do better, I think. Let's let b equal 0, since I know possible values for f of 0. So then we'll have 2 times f of a should equal 2 times f of a times f of 0. Okay, now, interesting. So if f of 0 equals 0, then the right-hand side is always 0. So if f of 0 equals 0, then f of a equals 0 for all a. And so the only way that f of 0 equals 0 is this trivial case. And so if there are any other solutions, we can say without loss of generality that f of 0 should equal 1. And now this equation doesn't give us any more information. Okay, so we'll assume f of 0 equals 1. what else can I do? What other special case can I look at? I think that how about let me pause for a second here. Get a drink of water. Okay, so since I know that f of 0 equals 1, let's let a equal b so that I have f of 0 on the right hand side. So I have f of 2a plus 1 equals 2 times f of a squared, if a equals b. So here, what I'll do is I'll just subtract 1 from both sides of the equation, and I think we've got our answer here, because 2 times f of a squared is positive, no matter what f of a is. It's a non-negative number. So f of 2a has to be bigger than or equal to -1. That means that -2 is an impossible value. All right. Pause here to take care of some house business. Okay, for 23, I'm going to tell you the answer first, and I'll go through one way to solve it at the end. But I'm not sure if it's the most efficient. It's a little bit of a grind. So the answer is 11, and so the number of possible values. So we're rolling a 6-sided die n times and finding product of those n numbers, and we're wondering how many different possible values for that product are there. Well, for one value of n, there's 936 possible products, but the general formula is that the number of possible products is n plus 1 squared times n plus 2 over 2. And now 936 happens to have a factor of 13. It's 13 times 2 cubed times 3 squared. And so how do we get a factor of 13? Well, looking over here, n has to be either 11 or 12, and 12 is not an option. And if you double check with n equals to 11, then yeah, 13 times 12 squared over 2 is should be just the right number, right? 12 squared is going to give me 2 3s and 4 2s, but we're going to divide by 2, and it'll be exactly what we want. So I'll go over one way of getting this formula, but I'll do the rest of the contest first. All right, here we have A, B, C, and D are positive integers satisfying all the following relations. So A, B, C, D have prime factors only 2, 3, and 5, and their total product has this many total of each factor. And then we have a least common multiple for each possible pair, each of the 6 possible pairs of numbers. And so I want to find the greatest common divisor of all of these. So basically, if I think about like A is going to be 2 times 3 times 5 with some exponents here, and I'll call the exponents a sub 2, a sub 3, and a sub 5, and I'll use the same convention for B, C, and D. And so like the facts I know is like A2 plus B2 plus C2 plus D2 equals 6. Right, and the same thing corresponding, A5 plus B5 plus C5 plus D5 equals 7. And so now we look at the data here. When I look at the least common multiple and so like let's just focus on one column at a time. So focusing on the 5s, right, between A5, B5, C5, and D5, the largest, LCM is going to be the larger of the 2 exponents. And so 3 is the largest possible exponent. and it happens with all the LCMs with A. So I'm going to say that A5 has to be 3, right? Because among B, C, and D, the largest exponent is 2. And actually, if I have any pair of B, C, and D, at least one of them has exponent 2. But the total sum of the exponents is 7. So although I don't know which 2 they are, the other 3 exponents of 5 have to be 0, 2, and 2 in some order. And so that means that the greatest common divide, that means that one of these 4 numbers is not a product, is not a multiple of 5. And that means that the GCD is not a multiple of 5. And I can immediately eliminate 3 possible answers. And now that I look at this, and I can use the answers that exist, I know that there's got to be one factor of 3, no matter what. And so the only question is the 2's. Is there any number that is not an even number, right? And so again, looking at the first 3, looking at all 6 of these, the largest exponent of 2 is 3, and it looks like A has to be that guy. So A sub 2 has to be 3. Now knowing that the sum of the exponents is 6, right? And knowing that between B, C, and D, at least one of them is a 2. Well, one of them has to be a 2, and then between B and C, one of those exponents has to be a 1, and that's all 6. So one of them has to be a 0. And therefore, one of the 4 numbers is not an even number, and so the greatest common divisor is also not an even number. Okay, finally, question 25. I've got a pentagon with a given area, a regular pentagon, and then I'm folding the vertices in. So let me draw my pentagon here. They're not totally regular, but it's okay. So so like 2 things to think about: the area, and then what happens when you fold. And so if I draw these lines from the vertex to the center point, right? Then when I fold, the crease mark is going to be the perpendicular bisector, right? And the intersection of those perpendicular bisectors is going to be the vertex of the smaller pentagon after I've done folding. Okay, so let me set up some variables here. Let's let x be half the length of this original, and so the 360 divided by 5 is 72 degrees. So that's the angle here. So the area of the big pentagon is 5 times, and now 5 times the area of this triangle that I've drawn. And so the area of this triangle is 1/2 times 2x squared times sine of 72 degrees. Okay. Whereas if I find the length from vertex to center of the smaller pentagon, let's call that length y. Now by symmetry, that's going to bisect that 72-degree angle. And so I can find y, right? X over y is going to be cosine of 36. So y is going to be x over cosine of 36 degrees. And the area that we're looking for, the answer to the problem, is going to be 5 times 1/2 times y squared. And y is x over cosine 36 degrees. So square that, and then times sine of 72 degrees. And so I never need to calculate what x is. I can use this top equation here. I wish I had a 2 multiplying my x. If I put a 2 next to the, if I put a 2 here inside the square, then I better also divide by 4. And so now I can use my 5 times 1/2 times 2x squared times sine 72. So I have 1 plus root 5. And then I'm going to be dividing by this 4 and cosine squared 36 degrees. So I've got my answer as long as I know what cosine of 36 degrees is. I do know that cosine of 36 degrees is 1 plus root 5 over 4. And so if you don't know that, then you have to figure it out. But knowing that, we can calculate our answer. We're going to have the one of the 1 plus root 5 is going to cancel with the numerator. So I'll have 1 plus root 5 left down below. One of the 4's is going to cancel with the 4 in the denominator. So I'll have a 4 left up above. And rationalizing my denominator, I'm going to have multiply by the reciprocal, by the conjugate. So I'll have negative 4 down there, and I'll have 4 minus 4 root 5 up there, and that simplifies to root 5 minus 1. So that's my answer. Now, 36 is not a normal special angle, but if you want to calculate the cosine of 36, one way to do it is to start with a isosceles triangle that has 36 degrees on one vertex and 72, 72 on the other. And then if we call the original side, the long side length 1 and the short one x, then the idea is bisect this angle. So now we have 36 here. And so we have 36, 72. So we have another 72 degree angle there. And so we have a similar triangles. And so x squared is the length of the smaller base here. And so what we have left here is 1 minus x squared. But because we have 36 degree angle here and here, this is another isosceles triangle. And so 1 minus x squared has to equal x. And so we get some kind of, it's a x squared plus x minus 1 equals 0. So it's a golden ratio type of quadratic. So x should be minus 1 plus root 5 over 2. And now you can use law of cosines to write down an equation for cosine 36, and you can calculate this value. So it's a little more work if you don't know that ahead of time. Okay, so that's the contest. The last piece to explain is how do we get this equation for the number of possible products when you roll roll a die n times and multiply out all the values. So I'll explain that on a separate sheet of paper here. So the product has only 2, 3, and 5 are the only prime factors. And and if I'm rolling n die, then for example, C could be any number between 0 and n, right? And the same thing for B. But my factors of 3 could come from either 3s or 6s. A, right, my factors of 2 could come from 2s or 4s or 6s. And 4 is 2 squared. So A could be as large as 2n if I roll all 4s. And so it's a hard to count problem because I could also roll 1s, and so the sum of these exponents could be, it could be 0, right, in the smallest case scenario. So one way I thought about counting this up is think about the possible values for C and for B, and make a little grid. and let's fill in the grid with the number of possible values for A. Right? And so, for example, if B and C are both 0, then I'm only rolling 1s, 2s, and 4s. And so my exponent of 2 could be any number from 0 up to 2n. So there's 2n plus 1 possibilities here. Right? And as I roll 5s, then I'm going to be decreasing the possible number of exponents by 2 each time, right? If I roll 1, 5, then I only have n minus 1 other rolls, and so at the most I can get 2n minus 2 factors of 2. And so all of those possibilities plus the possibility that A is 0, I have 2n minus 1. And then going to the far end of the table, if I roll all 5s, then there's only one possible value, right? Then so the table is filling with number of possible A's. Now, moving up, right? If B is not 0, so yeah, so this is going to be all the odd numbers here. Right? If I roll n minus 1 5s and 0 3s or 6s, then my exponent of 2 could be either 0, 1, or 2. So there's 3 possibilities. Moving up the table a bit, if I roll just 1, either 3 or 6, then that's one less possible 4 I can roll, but I might get a power of 2 here, and so I'm going to end up with 2n possibilities. All right, so moving up the table, every time I roll one more multiple of 3, it'll decrease the maximum possible multiples of 2 by 1. And of course, the total number of die that I roll is n. And so my table is going to be filled with only elements on the diagonal here. Right? And if I roll all multiples of 3, then, depending on how many 6s I rolled, there's n plus 1 possibilities. Right? So the exponent of 2 is either 0, 1, 2, 3, all the way up to n. And so we're going to see some kind of pattern here where reading from right to left and going up the columns, I have a 1, and then I have 2 plus 3, and then 3 plus 4 plus 5, and all the way up to n plus 1, up to 2n plus 1. And so, so the way I thought about to write down this product, right, is, how do I say? I've got 1 from the rightmost column, and then from the next column over, I've got 1 extra in each box. So I've got 2 boxes, 1 extra in each box, and then once I take out the extra, I've got 1 plus 2. And so this is the pattern that's going to follow. In the third column, I have 3 extra boxes. I have 3 boxes. I have 2 extra in each box, and then I have the sum 1 plus 2 plus 3. And I have n plus 1 total columns. So in total, my sum, my total number of possible products is going to be a sum. K equals, let's go from 1 to n plus 1 for the number of columns. And, right, and the term of like extra values, there's k boxes and there's k minus 1. I'll call it extra in each box. And then I'm also going to be adding up the numbers, all the numbers from 1 through k. So that's k times k plus 1 over 2. Okay, so let's consolidate, let's simplify this expression. So I have k squared, I have another half k squared, so this is 3/2 k squared. And then I have minus k, and I have plus a half k, and so minus 1/2 k. And so in total, I'm going to factor out the half, and so this sum is going to equal 1/2 times the sum of 3k squared. So that's, the sum of k squared is from k equals 1 to n plus 1 should be k plus 1, n plus 1 times n plus 2 times 2n plus 3, right? This is 2 times n plus 1 plus 1. And then it should be divided by 6, but I have this 3 over here, so only divided by 2. Oh, and I factored out, yeah, okay, good. And then I factored out the 1/2, so I still have a 2 here. And then minus the sum of k's from k equals 1 to n plus 1 is going to be n plus 1 times n plus 2 divided by 2. Okay, so we have to take this whole expression and simplify it a little bit. And what I see is I have a common factor of n plus 1 and n plus 2. And so I've got 1/2 times n plus 1 times n plus 2 times and actually I'll factor out the 1/2 also. So I have 1/4 times that, and then I have 2n plus 3 minus 1. So 2n plus 2. Okay, and so I can factor out a 2 from here, and I can write my final answer as 1/2 times n plus 1 squared times n plus 2. So that's my general expression for the total number of possible products. And that was what I had over here. The total number of possible products equals 936, and we have to find the n that makes this equation true. And because n is an integer, one of these, n has to be 11 to make it work out. So, okay, I kind of feel like because this expression is so simple, I feel like there must be an easier way to find it, but I haven't come up with a way. It seems a little tricky with the fact that your powers of 2 can come from 2s, 4s, or 6s. So drop a note in the comment if you have a better idea. All right, that's it for now.